2015, AP Physics 1, question number 3. All right, block initially at position x equals 0. So remember, that is the original, okay? And in contact with the uncompressed spring of negative mass. So I'm assuming the spring has natural length like this, okay? And so this is uncompressed, so there's no force at the point if the mass is here, okay? Now the block, but here it says it's in contact, okay? So I guess it's like there's a spring here, there's some kind of block, like a panel here that's pushed like in. It's not like a hooked. It's not like these are connected, because if it's connected, this will oscillate back and forth, okay? But it looks like it's sliding away, so it's not like completely fixed, okay? So it's you can push it until you reach that point, but once you reach that point, the spring will probably lose contact with the mass, okay? So that you have to be a little careful with this. All right, the block is pushed back along the frictional surface, so you push this back. So right now it's compressed, okay? So if it's compressed, you know energy is stored there as in terms of potential energy, and probably it's going to turn into kinetic energy when it gets released, okay? The block is then released at x equals 0, okay, which is that equilibrium, which when you get the maximum speed actually, because spring will be pushed until, apply force to the right. If you apply force, you have acceleration. If you have acceleration, it gets faster. Once you reach that point, probably spring cannot push anymore, so it's gonna move with maximum speed at an instant, okay? And the block enters rough part, okay? So it enters rough part. So I guess there's like friction backward. And eventually comes right at x equals 3D, okay? So it comes to stop at that point. The coefficient of kinetic friction, blah, 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 was mu, okay? So I guess this is mu k, right? Let's leave it as mu. Now, on the axis below, sketch label the following two quantities as function of position, okay? This is function of position, not function of time. From negative d to 3d. You do not need to calculate the values, okay? But same vertical scale, so you have to scale it. You don't have to get the numbers out. You can't really get the number because it's a variable now. But you have to scale it, okay? And kinetic energy of the block, potential energy of the block spring system, okay? That's the potential energy. So basically, that's energy stored in spring. So before we actually sketch this, let's see what's happening, okay? So I'll call this point number 1. I'll call point between, so it's fully compressed, and then it's moving right. I'll call it number 2. Then I'm gonna call number 3. Then I'm gonna call number 4 while you're moving, and number 5. So as time goes on, the block moves from position 1 to position 5. I want you to think about like what happens on each different case. So at point 1, spring is completely, fully compressed at that point. So there will be energy stored in spring. So let's look at in terms of energy and in terms of actually force. And let's look at acceleration too, okay? So at point 1, the total energy is stored as 1/2 kx squared, which is the potential energy of spring, 1/2 kx squared. But right now, that's the maximum compression. So energy stored will be 1/2 kd squared, right? At that instant, the force on spring will be k. Remember, force is negative kx. I'll explain one more time. Force is negative kx. This is restoring force from the spring. This negative sign means it's opposite direction of x. X is the displacement. Basically, right now at position 1, x is in that direction, okay? So x is backward because you compressed in. The restoring force from the spring will be negative x direction, okay? That's what it means. But if you look at magnitude, just kx, okay? So force from the spring will be kx, which equals ma at an instant. But remember, you're holding it right now. You're holding it probably. So you get acceleration. You get the actually maximum acceleration because your acceleration will be kx over m, but x is now maximum, which is now kd over. I didn't care about positive or negative d because I know this acceleration will be the right direction, or you can think this as magnitude, okay? Now, what happens in between 1 and 3 while the force is pushing? Okay, so right now, energy stored on spring, which is 1/2 kx squared, I'll just call it kx squared, but this x is smaller than d because right now your x is like this much. Okay, that's how much it's compressed, and in return the block will gain kinetic energy, which is 1/2 mv squared. So I'll just call it v2 squared. So this energy stored in spring is transferring to kinetic energy, right? And force is getting reduced too, because force equals kx, which is ma, but now x is this length, which is smaller than d. So magnitude of x is smaller than d, so acceleration is also smaller compared to the first position. Okay. All right, and position 3, right now it's not compressed nor elongated, so energy stored in spring will be 0. That means all of this energy which converted to kinetic energy, right? So you have potential energy of the spring is 0, you have maximum kinetic energy 1/2 mv, I'll just go v3 square, but this quantity has to be equal to that quantity, right? Now up to here, you do not lose any energy here, okay? Now, so right now you're moving fastest at that point, okay? Now, what happens while you're sliding, what's gonna happen? So the only force right now you have is actually force of kinetic friction, which will be force of friction, which is mu k normal force, by this is the simple case, mg gravity down, normal force up, this has to be in equilibrium in the y direction, so Fn is mg. So force of friction is mu k Fn, but Fn was mg, so that's the force of friction. So you're actually applying force backward. Now this is mu k mg, I'll just put negative sign there, notating this is backward, which equals ma, so your acceleration is also backward too, okay? Your acceleration will be negative. So your acceleration will be basically negative mu kg if you cancel this out, right? So basically you're slowing down. Remember, you are moving to the right, but because of this force, your acceleration is backward, so this velocity will get smaller and smaller and smaller. You can also say there's a work done by friction. Work done by friction is negative right now. That's why your kinetic energy is decreasing. You can explain like that too, okay? And finally, at 3D, at position 5, 3D completely stops. Now, if you think about it, so this is position 5, this is position 3, and position 3, all the energy is kinetic energy. Now, all the energy is gone. The reason it's gone is because work done by force of friction, which is, what is work? Work is F dot D. So force of friction, call it mu K, times displacement in that direction. So F dot D dot product, remember, you multiply two component parallel, but this will be negative because force is backward, displacement forward, and this force is the mu K mg, remember, and this has to be equivalent to that. That's why you get completely stopped. I think that's the full picture, and I tried to explain in detail as much as possible. Okay. All right, let's go back to this. So after sketch kinetic energy. Okay, what happened to kinetic energy? What happened to potential energy? Potential energy is 1/2 kx squared. So you get, this is a quadratic format. So you get the maximum potential energy at negative d. So it's gonna probably go down like this. So that is because it has to be quadratic format. Okay. Then what's the kinetic energy? Kinetic energy will increase, right? So kinetic energy goes up, like I'll use blue line. Kinetic energy goes up like that. And if you think about what is total energy at that point is this plus 0, which is basically same point here. Total energy here is this plus that. No, actually I have to say this plus that, because they are same. So there are 3 here, another 3 there, so which will give you 6, right? Right here you have 0 plus 6, which is this. So total energy, if I draw it as black, will be constant. Okay, so that is the total energy. Okay. Now What happened to potential energy of block system? This potential energy, after you reach here, it's not gonna compress nor gets lengthened out. So this will be probably 0 throughout until you reach 3D. What happens to kinetic energy? Kinetic energy will decrease, but how does it decrease? Remember, kinetic energy decrease because of work done by friction, and work done by friction is force of friction times displacement. And remember, it's negative. And force of friction is mu k mg, which is normal force times d. So it's basically linearly dropping if you look at it as a d. Okay, so if d is 1, that's how much it drop. If d is 2, that's how much it drop, because it's not going to change. So this one linearly decrease. I have to use blue. Blue is the kinetic energy. So this linearly decrease until you reach here. Okay. So this is kinetic energy. Red was potential energy, and black is the total energy. But total energy will be here like that, and it will be same as kinetic energy at the end, I guess. But you know, you don't have to really worry about that part. Now moving on. Spring is now compressed twice as much, which is 2D. Remember before it was compressed by D, and then it slide out to, was it 3D? I think it was 3D, right? Yeah, it was 3D here. So when I compressed D, it, remember the work done by friction went to 3D, right? So once again, energy stored in spring 1/2 kd squared becomes maximum kinetic energy here 1/2 mv squared. Now that is work done by friction, which equals mu k mg times 3d. So these are all equal, okay, in terms of magnitude. Again, force of friction, displacement, work done, okay. All right. Now, if you compress 2D, that means you doubled D, right? If you double D, what's going to happen to energy? If it's 1/2 k d squared, but if you doubled D, it's 1/2 k 2d squared. It's almost same, except you'll end up 4d squared coming out, so you'll have this 4. That means total energy stored will be 4 times, right? All right, then what happened to velocity here? Okay, I know total energy stored will be 4 times. That means this 1/2 mv squared has to be also 4 times. That means this velocity is actually gonna be 2v, okay? Because if you, instead of v, put 2v, there'll be 4 in front of it, okay? So I know velocity at the equilibrium will be twice in this case, but again, they didn't really ask you that. So nu is 2 times old. Now, so if this gets quadruple, this has to get quadruple. Once again, to get quadruple here, remember d becomes 2d, then you get quadruple. Then if v becomes 2v, this gets quadruple. Now you have to quadruple this, right? If you want to quadruple this, you can't really change mu k. Mass does not change, d does not change. So only thing you can change is actually d, right? So if you want to quadruple this, you have to do 12d, right? That means it's gonna go into 4 times of this distance and stop. Right? So here, so I think that's the full explanation of this. What was the reasoning? Three reasons that since the spring will be compressed twice, the block will have more energy. Okay, that's true. That's true. Okay, it will be actually 4 times energy. You leave the spring, so it will slide further along and push on 60. So that part, it's gonna go farther along. That's true. This is true, but it's not gonna be 60, right? Because 3D becomes 60. That's twice, right? But remember, energy was 4 times bigger. So 3D has to become 12D to get to 4 times bigger, right? So which aspect is correct? Basically, D becomes 2D. You have more potential energy stored in spring, so it's gonna go farther apart. It's gonna go more than 3D. But what, right, is correct? Explain why you arrive at answer. That's how you explain. Which aspect is incorrect? The incorrect part is because the potential energy stored in spring is 4 times. Work done by friction has to be 4 times. That means instead of 3D, this has to go to 12D, okay? That's what you have to explain, okay? Use a quantitative region including equation needed to develop expression for new final position of the block. I think I already showed you using this, but I'll write one more time. So 1/2 new final position, okay? So 1/2 kd squared equals force of friction times, actually I'll put it this way. So that was the total energy you had minus work done by friction. Force of friction times 3d is 0. So 1/2 k2d squared minus force of friction times, I'll just call this a new distance. So I don't know what it is. This has to be 0 too, right? Then this distance, so here, and this distance, because you have this 4 in front, you have to get 4 out here, or you have to get 4 out here. So I know this has to be 12D. You have to elaborate something like this, okay? Now you can actually solve this, but this gets messy, okay? Unless, you know, I don't want to go to too messy equations there, okay? I just want us to think about, like, this gets quadruple, this has to get quadruple, that means 3D has to become 12D. I think that's good enough to explain. Explain how any correct aspect of its using part be expressed by your mathematical relationship. So here you can say if D gets larger, this gets larger. And incorrect, explain why you're in part C. What's part C? Correct any incorrect aspect. So incorrect part is it's not doubled, right? It's quadruple. Again, it's the same thing, right? I think that's good enough.